Hello, let's continue learning about neural network and looking in different components. Last time we finished looking at the training process, and this time we are going to look at the evaluation process, basically how we get to to this occurrence and how we look at it as we train, right? Um, Before looking at the evaluation, we'll need to go a little bit back and start looking at a little bit deeper into the activation functions, and which it is they are here. And we in our project we are basically working with two activation function, and this activation function is basically Relo and Softmax. Okay, and activation function, it is what we use to bring some non-linearity to our model, and consequently prevent overfitting. What that means, in simple words, is that by adding some activation function to our model, we will be able to generalize our model. And basically, when you generalize, what that means is that enable us to give different image to our model, and the model still be able to predict it correctly. If you don't have those non-linearity or generalization, the model will perform well only against the images that were used during the training, right? So that is basically why you are trying to achieve non-linearity on our models, to be able to train with images and use different images to be evaluated, right? And that's basically the process we do. So when you are building our model, we separate our data into training and evaluating, testing image. So we train with these images, but when you are evaluating, we use different images, and this would give us a good idea about the generalization of our model. Okay, so why use an activation function? We use activation functions to bring some non-linearity to our model, which will consequently help the model to generalize to different inputs. Okay, let's just have a quick look at those two activation functions that we are using. There is many out there, so we will focus only on those that we are using here, even though in another project that we'll be exploring later, we use another one which it is called sigmoid, and we are gonna have a quick look at it as well. But without further ado, let's start looking at Relo first. And when you look at our model, our Relo, we'll be using Relo into our hidden layers. Okay, let's see if you can look at it here. Yeah, so when you're creating a model, you can see that you pass the activation function Relo in the hidden layer and in the input layer, but in the input layer we're not really using it. And our output layer will be Softmax, and you're going to understand why we are using different and why Softmax and not Relo on the output. Let's understand a little bit what is the Relo first and how it works. So Relo, it's called the rectified linear unit activation function. Better than look at the comments is just look at the code, right? So if it is the output, it's bigger than 0, we use it, and the value itself. If it is below 0, we return 0, basically. And in other words, the neuron, by doing those, we are defining if the neuron will be fired or not. Okay. And softmax, it is an activation function that transforms the raw output of the neural network into a vector of probabilities. Essentially a probability distribution over the number of classes. So in our case, softmax, we have 10 classes, and what softmax is gonna be doing it is generating a vector of probability of 10. So basically the output of softmax will be something like this, but in this case we are saying 5 classes, but in our case, because we have 10 classes, basically from 0 to 9, it will be 10, a vector of 10 probabilities. And how we know which is the final output, it's looking at the highest probability. So for example, in this one here, we have different probability for different let's say class, and you just take the highest by using argmax function. And in this case here, for example, we receive the output of our neural network, and basically after passing by the softmax, and you're gonna get something like this, and then you're gonna pass to a simple function that you just basically look at the highest probability, or we call confidence as well, and take the vector, and we receive the vector position, and now we know that's the number 3 in our example here. When the activation function it is used, it is basically on the output of the layer, right? So looking at our example, looking at our architecture here again, this should be, activation function will be used right before the output of our layer. Okay, and you can see that in code as well. If we look at the network, let's see on the layer sign, process feed forward, we can see it here, right here, right? As the last piece, we loop over the output, applying the function, the activation function. Okay, so and just then we set to our output. So it's the last process during our feed forward. Okay, and you apply that only against the output. Let's have I think we have a quick look at the output itself. Let's run our model in debugging mode. And let's run it. And now we can see and during the feed forward, just before the activation function, and you can see the activation function is Relo at the moment. And let's look at the output before the activation function is applied, and you can see that there is many minus data here, and since you are using Relo, you should be seeing those output become 0. Let's step over and look again at the output, and now you can see that the minus it's 0, right? Let's now move and see the next activation function in practice. In this case now softmax. Look at the output, and you can see the output, it is now only 10 layers because it's the output layer. and you can see different values, including minus and some positive data. And now we are gonna make that become a vector of probability of each for each class. Looking again at the data, and now you can see that it became probability of for each class, right? And we basically get the highest probability or confidence, and that will be our prediction, final prediction, right? And we can see it here. So basically that will be the output of softmax, and then we use argmax to get the highest probability. And you can see the function is very simple. Just take the max and find the index of that vector for that value. And it is basically that. I think that shows the whole idea behind the activation function. And now you can go and explore it by yourself. And then next step would be to learn a little bit about different activation function and when to use each one. So that would come with experience, and again, it's one of the things that would have to be exploring, right? So we will continue in the next lesson about the evaluation process. That I think would be enough to cover only the activation function itself.